Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper theory. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Most of the time, many students, they feel P3 exam is very difficult. But P3 exam is the easiest exam if you have good understanding of basics of physics. If you're struggling with P3 exams or you have kind of fear about P3 exam, then watch this video carefully, and also I have uploaded an other video from 2023, one or two videos, and also I have uploaded exam tips for P3. If you watch all of them, and then you will feel there is no more fear about P3 exam. So watch them carefully, and if you have any questions, you can also leave your questions in comments and I will try to answer as soon as possible. So watch this video carefully and try to improve your practical skills. Mean how to record data, how to take measurements and other precautions. So you just need to understand few points, means not too many concepts about P3. If those basic concepts are clear to you, then P3 exam is quite straightforward one. And P3 exam is very important exam to understand physics, because physics starts with experiment. Mean it starts with measurements. So understanding of this paper is very important to understand physics in a right way. Question 1 says a student had a stack of 50 sheets of paper. He measured the dimensions shown, means x, y and z. The student used a balance to determine the mass of the stack of paper. The reading is shown below. State the resolution of the balance. Resolution is the smallest measurement we can take with the help of that instrument. So smallest measurement. Now if you look at this one, here we have this decimal place. This is the decimal place. So how many decimal places we have here? We have 3 decimal places. It means that the smallest reading we can take with the help of this one. So this is when nothing is placed on this. So we will see this one. So what is the smallest reading we can take with the help of this one? The smallest can be 1, means 0.001 kgs. So this one is the resolution of this balance. So resolution simply is the smallest measurement you can take accurately with the instrument. Smallest measurement you can take accurately. So very important one, accurately. The smallest measurement. So in this case we can take the smallest measurement, that is 0.001. So let's say now we have another balance. The reading on that balance is 0.01 for example. So what is the resolution of this one? The resolution of this one, you will simply say this is 0.01. And if we have another one that has resolution, that is, let's say the reading on the balance is given to us, that reading is, let's say that is 2.50. So what is the resolution of this one? So you will say this is 0.00. It means the resolution will be 0.01. So these two balance, they have the same resolution. And if we have another balance, reading on that is 2.4. So what is the resolution of this one? So we can simply write down first of all 0.0, and the last 0 you can write down, this is 0.1 if the unit is kgs. So this is 0.1 kgs. This will be equal to 0.01 kgs. This is also equal to 0.01 kgs. So this is how you can determine the resolution. So the resolution of this one simply we can say is 0.001 kgs. This is. So you have to read the unit from the balance. Second part says determine the percentage uncertainty in the mass of the stack of paper. So how we can determine percentage uncertainty? So simply we can say this is percentage uncertainty. Percentage uncertainty for single reading, single measurement, this is equal to half resolution of the instrument, half resolution divided by measurement itself, means the reading we have taken with the help of instrument. So this is the formula, and you have to multiply this one by 100. So in this case, our resolution was equal to 0.001. So we have to divide this one by 2, and we have to divide by the reading of the measurement. Reading was 2.070 kgs. So this is in kgs, and we need to multiply this one by 100. So by 100. So if we solve this, we will get 0.024%. So this is how we can calculate percentage uncertainty, and this is only for one reading. If we have taken one reading, if we have taken multiple readings, so let me write down here for multiple readings, or you can say for multiple measurements. How to calculate absolute uncertainty? First of all, simply we can say how to calculate absolute uncertainty. So this is first thing you need to understand, how to calculate absolute uncertainty. We use half range method, means you will take the maximum reading minus you will take the minimum reading, means simply the range divided by 2. So this is the half range. But if some data is anomalous data, anomalies there, outlier, means one or two readings are totally different from others, you can simply ignore them, and then you can find the range of remaining measurements. So this is also very important point. And so we can find absolute uncertainty. If we have absolute uncertainty, then we can find the percentage uncertainty. So here we will have absolute uncertainty. So this is absolute uncertainty. So these are important points you need to understand step by step. So absolute uncertainty, we will be dividing by the mean value. Very important one. You have to calculate the mean of the readings, and then you need to multiply this by 100. So then you will be able to find the percentage uncertainty. Part B says the student used vernier calipers to measure the thickness Y of the stack of paper. Explain one technique he should use to determine an accurate value for Y. One technique. So first thing we need to understand, in this case we are using vernier calipers. So we can talk about vernier caliper. So we can talk about instrument. As we are using vernier caliper, we have to check vernier caliper for zero error. If it has zero error, we need to adjust the final reading. For example, if the zero error is positive, means the reading measured by the vernier caliper is higher than actual reading. And if the zero error is negative, so how about the final reading? So we can write on here the final reading we should subtract. So let's say we have, this is the measured value, and we have to subtract zero error in this case. So this is our reading, so we can say this is our reading from the instrument, and here we have zero error, so we have to subtract that. If zero error is negative, then the final reading we have to add zero error. Final reading means the actual reading. This will be equal to the reading from the instrument plus zero error. So we have zero error here. So this is zero error. So we can say this is zero error. We have to add or we need to subtract. It depends on type of zero error. So this is one thing we can do about instrument. So we can make sure what we measure from the instrument, that is right. And the second thing what we can do is, as we have the thickness, for example, in this case, so we have the thickness, this stack of papers, we can measure thickness at different positions, and then we can take average. The diameter of something, you can also talk about measure diameter at different positions and calculate average. In this way we can minimize random error. By measuring and taking average, we can minimize random error, and with the help of this technique we can minimize systematic error by checking zero systematic. So we can reduce systematic error if we check for zero error. So these points we can mention. Thickness whenever you need to find out. For example, I have these papers here. So you can see here I have these papers, and if I need to find the thickness of one paper, for example, if I need to find the thickness of one paper, I will take many papers, I will make a stack of them, and I will find the total thickness, and I will find thickness at different positions, and I will calculate the average total thickness, and then I will divide by number of papers, number of these sheets, so I can find accurate value of one sheet of paper. So these are the points you need to understand. We can simply say check for zero error, and with the help of this one we can eliminate systematic error. In the answer you should write down what kind of error it will minimize: systematic error. We can also say measure thickness at several positions and calculate average value. It will reduce effects of random error, mean it will reduce random error. So these are important points. Next time they can give you something little different. Maybe they can ask you to find the diameter of ring, diameter of any solid object. So the same point you can mention in that question as well. And if they ask you to use micrometer, for example, you can also talk about the same points. Part C says the student used the measurements from the stack of paper to determine the density of the paper. For part C1, determine the density of the paper in grams per cubic centimeters. So how we can calculate density? So this is the first thing you need to understand. Density is equal to mass over volume, means the mass of stack of paper divided by volume of stack of paper. So here we have volume, and the mass in the last part was given to us, mass was given, that was equal to 2.070 kgs. So we can convert this one into grams. So we have 2.070 multiplied by 10 to 3, so the answer will be in grams. We will get 2070 grams. So now we can write down the value of the mass, that is equal to 2070 grams. So this is in grams, and these values are given to us in millimeters, so we can convert them into centimeters. So simply we need to divide by 10. So here we will get 21.0 centimeters, and here we will get 4.27 centimeters, and here we will get 29.7 centimeters. Now we can plug in these values here. We have 21.0 and we have 4.27, all of them they are in centimeters, and we have 29.7 centimeters. If we solve this one, we will get 0.777 grams per cubic centimeters. Grams per cubic centimeter. So for this one we need to understand, as our given data, this has 3 SF. So you can see it has 3 SF, this has 3 SF, this has 3 SF, and this also has 3 SF. So the final answer also should have 3 SF. In the final answer we consider the least number of SF in the given data or one more. So the final answer is 0.77 grams per cubic centimeter. Second part says explain why making measurements on the whole stack of paper is better than making measurements on a single sheet of paper. We have already discussed about this one. So if you need to find the thickness of one sheet of paper, it's better to have many sheets together placed on top of each other, and then you can determine the thickness of one sheet of paper. So that method is a better one instead of just using one sheet of paper. Now let's try to understand why, if we have a stack of sheets of paper, why that is better to measure thickness of one sheet of paper. So let's try to understand that with the help of percentage uncertainty. So we need to understand percentage uncertainty. This will be equal to half resolution of instrument. So we have discussed this point at the beginning, and now we will discuss again this point to answer this question. Half resolution divided by the measurement. So here we have divided by measurement, and we have to multiply this by 100. For one instrument resolution is the same. For the same instrument, you need to understand, for same instrument, resolution is the same. But if we can increase this measurement, if we increase this one, it means the percentage uncertainty, this one will go down. So that's the reason we place many sheets of paper on top of each other to find the thickness of one sheet of paper. So in this case, we can minimize percentage uncertainty. I hope this makes sense. Now let me show you the answer, how you can write down your answer. This question has 2 marks, so you can mention 2 points in your answer. So these 2 points, if you write down in your answer, you will get 2 marks. First, you can say the measurements will be larger if we have stack of papers, and it will reduce the percentage uncertainty. So if you write down these 2 points, you will get 2 marks. So this is how we need to answer. I hope this one makes sense. So this is very important point, very important point. So you need to understand why we measure time period for many oscillations. The same is true for pendulum. Let me explain you a little bit about this one. Next time they can ask you a question about this. For example, you have a pendulum. You need to find out its time period. I mean time taken from this point to come to this, so this way, and to come back to this point again. So this is one time period. So when we need to measure the time period of simple pendulum, we always measure time for more than one oscillation, means at least 5 or 10 oscillations, and then we find the time period. So why we do like this? The reason is that if we have higher value of the measurement, we can minimize the percentage uncertainty. So the same reason is true for simple pendulum. Question 2 says, a student investigated the efficiency of an electric motor using the apparatus shown in the figure. The motor was connected in a circuit including a battery and a switch. The student connected additional components to determine the power of the battery. Power of the battery, we can simply say P is equal to VI. Complete the circuit diagram for the circuit the student should use. So we need to determine the power of the battery. So we need to find the potential difference. So we need to use voltmeter. So voltmeter. We need to find value of current passing through the motor. So it means we have to use ammeter. So these 2 additional instrument we need. And if you look at this one, we have the positive terminal of the battery. Then after this one, we have this motor. Motor is connected here. And after motor, we have the switch. And then this is connected with negative terminal of the battery. So simply, first of all, we can draw this is positive terminal of the battery. And this is negative. And here we can draw the switch. Positive terminal. So we can draw the switch here. So this is representing the switch. So we can draw this is the switch, and we can connect this one with motor. We need to find current passing through the motor, so we need to connect ammeter in series. So we can connect ammeter in series, and we also need to find PD across the motor. So we have to connect voltmeter across this motor. So this is how we can draw the circuit. So this one is over switch. So this is switch. As question said, complete the circuit diagram. So we can also label actually these components in the circuit. You can also label. So this is battery. You can write down this is ammeter. This one is motor, and this one is voltmeter. So it's better you can also label this diagram. Part B says the student closed the switch in the circuit and the motor lifted the mass from the floor. She used a meter rule to measure the height gained by the 1 kg mass in 10 seconds. Describe how she should measure a single value of the height gain as accurately as possible. You should include the use of any additional apparatus needed. Now, before we answer this question, you need to just imagine you are doing a real experiment. How you can find the height gain? So you have to first of all think about this one. So this is the best way to answer. tricky questions. Now let me explain you how we can find the height of this mass. In order to find height, we have to use meter rule. Now we cannot hold meter rule with this like this, so it's better we clamp the meter rule. So simply, first of all, we can say we can clamp the meter rule next to this mass. So this is our meter rule. We need to clamp this one, so we will be using retort stand. So this one is our retort stand, so we have to use the retort stand. So this is the rod of the retort stand, and here we have the clamp, so we can use clamp here to hold this meter rule. And also we need to make sure this meter rule is vertical. So how we can make sure? We can place set square. So we can place set square and we can check whether this one is vertical or not. We can also attach a marker at the bottom of the mass, so we can reading from the scale easily. So these are the points we need to understand. And also we need to understand, when we read the scale, we need to read scale at eye level. So these are the practical points you can include in your answer. Now let me show you the answer, how you can write down the answer. In your answer you can mention these 4 points because this question has 4 marks. You can say clamp the meter rule next to the rising mass using retort stand. We have mentioned that point. Use set square to make sure the meter rule is vertical, so we have already shown here. And attach a marker at the bottom of the mass. So here we can attach marker, something you can attach here. So this is the marker. Take measurements perpendicular to the scale using a set square, so we can avoid parallax error. So these 4 points you need to write down. So whenever you need to measure the height, you can talk about these points. Second part says explain why repeat measurements are appropriate for this measurement. In this case we are measuring height. So first of all we can say we are measuring height, so there can be parallax error. So when we are measuring, there can be parallax error. And we also need to measure time, in this case time for 10 seconds. So when we are measuring time, due to reaction time there can be errors. So due to reaction time. Now if we repeat these measurements, so the value of parallax error will be bit different. It can be higher slightly, it can be lower than the actual value due to parallax error. And reaction time also can be little bit higher, little bit lower every time when we repeat. So we can simply say these two, they will cause random error because the readings will be sometimes higher, sometimes lower. So it means that is random error. Now the question is how we can minimize this random error. Random error, to minimize, as we mentioned before, we can repeat and we can calculate average. By calculating average value, we can minimize random error, but systematic error cannot be minimized. So in this case we are taking more than one reading, so there is random error due to parallax error and also due to reaction time. If we take only one value, for example, so in that case due to reaction time our value will be higher than the actual value, so that you can say systematic error. But in this case we are repeating, so that becomes random error because readings will be sometimes higher, sometimes lower. So it means that is random error, and random error can be minimized by taking average. So this is how you can answer this question. Now let me show you the answer, how you can write down your answer. In the answer you can mention these points. You can say there will be a random error due to reaction time and parallax error, and random error will cause variations in the measure value, means sometimes value higher, sometimes lower. So by repeating we can minimize random error, and by calculating average we can get more accurate value. And this point is very important, so let me clean this one. So this is something you need to keep in your mind. Random error can be reduced. Random error, it can be reduced by taking average, but not systematic error. If you take average, we cannot reduce systematic error. Part C says explain how the measurements made by the student should be used to determine the efficiency of the motor as it lifts the mass. So pretty straightforward question is asking you to determine the efficiency. Efficiency, simply we can say efficiency is equal to useful power out. So we can say useful output power. So the main idea you need to understand, useful output power divided by total input power. But when we say input power, it means we are talking about total input power. So simply we can say input power, or you can say power input. So what is the input power? So input power simply is P is equal to VI. So this is the input power, means the power of motor. So this is the input power, P is equal to VI. And what is the useful output power? That is the gain in potential energy of this mass per time. So we can say the power out, that is the change in GPE of this mass over time taken, over T. So simply we can say that will be equal to mg delta H over T. So we can write on here, so this is mg delta H over, so we can write down mgh over T, so over T. So this is P out, this is P in. So if you write on this one, you will get 3 marks. 3 marks for this question. So these are very easy to get these marks. Simply if you understand what is efficiency, that is equal to P out over P in, useful P out over P in. And P out, useful P out we have, this is, and this is power in, mean input power, and we can find the efficiency. I hope this paper makes sense to you, and I also hope you have better understanding of these questions, and these videos are helping you to improve your understanding of physics. Please like and subscribe, and if you are looking for extra resources and one-to-one guidance, so you can also join Patreon. See you next video. And the remaining 2 questions from this paper, I'll be uploading before your exam.